Hello, everyone. I'm Jonathan Brendefur from Developing Mathematical Thinking Institute, and I want to talk about measurement today in the sense of the tools that we use and how important they are when we're first developing an understanding of measurement. And there's some tools that lead to a lot of misconceptions as kids get older. And part of the problem is we end up using a tile, a plastic tile a lot, and a cube a lot of times for measuring these different dimensions. So let's talk about what these are and why that is problematic. Okay, well, zero dimensions, we don't actually measure anything in zero dimensions. It's just a little point in space. But one dimension is imagining that point being stretched in one direction infinitely in space. And so that ends up creating this line in space. And then, well, how do we measure things that are like in a line? So as we're running a race, we're measuring the length of a desk, how tall somebody is. Then we have what are called linear, which has that word line in there, linear units. So we need to be able to measure that line. And so we have things like inches or centimeters or non-standard units. As we're first developing it, what do we measure that with? And stir sticks are probably one of the best things that we could use, or like spaghetti or string. But like stir sticks actually allow us to look for that iteration of linear lines. Because what we want to do is take that unit and iterate, copy it over and over without gaps and overlaps. That becomes a really important early idea for measuring. Then we're going to measure two dimensions. As we measure two dimensions, we have that same direction here of linear, but now we have a second direction. So now what are we going to use to measure so that we have no gaps and overlaps? We have to have some type of unit that tiles, that doesn't have the overlap. So the best thing is that's really nice is that regular shape of a square. So we have what are called square units. And that could be square inches, square centimeters, whatever we have, but that square unit, because that becomes really nice. And then what's appropriate tools to measure the different square areas, then we would actually use this tile, because then we can see that tile covering that space. Now in 3 dimensions, which is harder to draw here, but we have this direction, we have this direction, we have another direction. So if we're in space, in 3D world, what do we use? What shape do we use that we can, again, kind of tile or cover or fill that space with no gaps and no overlaps? And what that is a cube. So then we have that cubic measure from that, where there's no gaps and no overlaps. So then that becomes the appropriate tool for 3 dimensions when we're trying to look at volume of different sizes. So we have what are called cubic, and the cubic units. Just as an example, if we go back here, why is that problematic? So if we were to have some type of shape like a rectangle, and we said, how many square tiles? A lot of times what happens is students, so let me go back. If we want to do the perimeter first, we're first going to do linear, because a lot of times we do linear in area. We're in about 4th grade. What happens is they start using the tile, and they tile in the area, which is fine, but then they use that same tile to measure the perimeter, and they do this. Now, what you have to focus on is with the tile is the edge of the tile is what we're focusing on the linear measurement. However, they're counting 1, 2, 3, and what students do is they want to cover the entire perimeter with that shape. And what happens is you see that they get these miscounts because they're using the wrong tool for measuring linear versus a tool that's really meant for area. So again, thinking about which tools, we want to be able to have something that's a linear tool to measure things that are in 1 dimension or linear, square units to measure 2 dimensions to cover an area, and a cubic unit to measure things in 3 dimensions. So hopefully this helps you out in thinking about what are the appropriate tools we use as we measure in things in 1 dimension, 2 dimensions, and 3 dimensions.